meeting?
No Zoom, yeah. Okay,
All right. Hi, everybody. I'm sorry I'm late. I got too excited talking in the Q&A and I ran a little late to my own 3D printing class. I'm really excited to do a quick overview here of 3D printing design. And so I'll take you through, and the first thing that you may need is a Tinkercad account if you want to follow along. If you also just want to watch, that's totally fine, and we'll do that as well. I'll take you to that website in just a moment. And I'm going to also just show you that this is an example of the kinds of 3D printing that we're doing. There's a few different types. This is fused deposition modeling 3D printing, and it's where the filament is basically heated up, pressed through a glue gun, sort of hot end interface, and then printed layer by layer, starting from the bottom of the Yeti, going all the way to the top of the Yeti. I have, if you watch the Q&A, also this very large boat. That's another great example of something made with that fused deposition modeling process. And at the library, I also mentioned that we are introducing eventually access to a resin printer that uses UV light basically to essentially with lasers cure the resin into a shape. And this is actually very relevant for what we're going to be doing today in the session. This beautiful object is a little 3D model that a staff member made of the Milner Library. So I'm going to be taking you through doing a little bit of fun modifications to the outside of the building. We know that people have opinions and we've heard them, but I think we can have some fun with that today. So first thing that I'm going to do is I'm going to just share my screen so that I can get everybody over to the website. And just a moment here. Okay. Have it here somewhere. Just gonna go ahead. And we're going to basically essentially with Tinkercad here, and I have my screen shared. This is on tinkercad.com, www.tinkercad.com. This is a free web modeling application that's provided by Autodesk, and it's something that we used a lot in the library because it's so friendly for beginners. People who are quite young, I think we've had kids as young as 3 or 4 actually make successful 3D designs. Who knows what the upper age limit for this is? I have definitely had adults start with this. Even people who have crafts experience or, who have been working in the past on, very more complicated design and building projects. If they don't have any digital design skills at all, we might bring them into Tinkercad as a way of getting started. If someone was moving past Tinkercad, we might be taking them into Fusion 360 by Autodesk. That provides for some more high-powered modeling options, I'll say, for more complicated kinds of designs, especially for functional objects. So first thing is I'm going to take you through a bit of an overview of Tinkercad itself, and I'm just going to move our library off of the frame for a second. And oh, before I do, this is modeled by a Makerspace staff member, so this is not it's not a truly accurate architectural model of the beautiful building. It's a little rough around the edges in terms of some of the swoopy geometry that I love when I'm walking down near Jasper and down on 99th or 100th Street. So this is something that a staff member kind of took a look at what the library's renderings were and sort of modeled it. So I'm just going to move that over for a moment so that I can kind of show you the basic interface. So I've been basically panning using my right mouse button, if you have one, to change the view to kind of see, the different x, we call it the x and the y and then the z axes. And I have on the right hand side here some of my basic shapes as well. So I'm just going to start by grabbing a basic shape and pulling it into the work plane. So as you can see, as I've pulled this into the work plane, I have essentially a nice little red box here, and a bunch of arrows have popped up. What these are is these are designed to basically help you with transformations. They also give you some information about the object itself. So this is a 20 millimeter by 20 millimeter square. And if I, grab the square by one of those corners, I can immediately transform the shape and the dimensions at the same time. And that's pretty important when you're 3D printing. You want to kind of know what the actual size of the thing that is that you're working on, especially if you're designing a functional part. For example, I was helping a friend recently who's working on a speaker cabinet and was building a little faceplate for some of the inputs. And so we had to figure out exactly what that faceplate dimension had to be, and we had to be pretty precise and make sure that we didn't mix up our inches and our millimeters and that sort of thing. So that's good to know. Another thing that I'll just direct your attention to here is these little arrows. These allow you to rotate the object 360 degrees and tells us the degrees of rotation as well. This one right here is pretty important. This allows us to change the Z position. So this is the up and down position of the object. So I now have a box hovering in midair. That's not concerning at all. But that's really great in terms of as you're starting to build an object that's got a few more parts and a little more complicated. It's a really good feature to have access to. So one of the other things that I'll kind of show you really quickly here from a 3D printing perspective is that I'd mentioned earlier that my Yeti or my boat, that they started from the bottom and they went to the top. There might be a song about that, I'm not sure. But anyways, so if we were to submit this box for 3D printing at the library, or we've taken the self-serve 3D printing course, one of the things that we want to make sure is that our object, because of that starting at the bottom, going to the top, we want it to be right on the zero position at Z, so that it's sitting on the work plane properly. So that's something that staff can help people with if they have an issue. Oftentimes models in the software will automatically be dropped onto the plate and it's not a concern. Sometimes with how they're dropped onto the plate could be a bit of an issue, but so far not a concern in this case with a really simple object. So that's our box. Another thing that Tinkercad allows you to do that I want to show you is it allows you to transform objects by cutting holes in them. So I'm just going to grab on the right hand side here my cylinder. And basically this cylinder, it's already sort of pre-cut as a hole. I can basically kind of take any of these objects, though. I could take the cone as well, and I could drag it over, and I have a little box that'll pop up, and essentially I can play with its properties. So I have the color, not the color that it prints, but the color in Tinkercad, and then whether it's a hole or a solid object. So I could turn this cone into a hole as well. So if I want to, start to build something that's a little bit more complex, I can basically take all of these holes that are inside this solid object, and I can use this tool up here, which is the group tool, and this creates basically a permanent join of these objects. And so I've just pressed group, and essentially what I have here now is I have not just a little box or a little rectangle that's 3D, but also now something that is a totally different and new object. So it could be, the start of something great, could be the start of a hamster house or something like that. Tough to say. So those are some of the really fundamental operations that you can do in Tinkercad, and really important to kind of understand as you're getting started. So just kind of looking at some of the things that we can do, I mentioned that we have the Milner model, and I'm going to actually just delete our box, and I'm going to bring the Milner model back over. And so there are actually some fun things that we could potentially do just with what's supplied in Tinkercad itself. So as an example, I'm just going to scroll down here, and we have like a heart. So, the I heart EPL, you may see that as you visit the Milner, and we can right here just put our heart right on top of the building. And I'm just gonna pan a little bit so that I can line this up. We kind of talked about that a little bit before. So there we go. I've now got a beautiful heart on top of the building, and I can basically group it by doing a selection, pressing group, and now it's a permanent feature of this 3D printable model. Just talking about this as something that we would 3D print, one of the pretty big challenges that our fused deposition modeling, our FDM 3D printers face is unsupported 35 or 45 degree angle, greater than 45-degree angle overhangs. So this model actually, if we were to print it out for real, we may need to add some supports, because that's a pretty sharp overhang there, and we wouldn't want the plastic to get dropped and for things to start to droop. Nobody likes to see that on real buildings, but definitely not on 3D printed ones either. So this is, a basic modification. I think there are some more fun things that we can do though as well. We can go ahead, and there's a bunch of different categories of things that you can add to the library. So for example, we have some dinosaur parts that have been loaded in, and we could potentially put like a dino head. We have the wall and we have the dinosaurs happening, so why not kind of combine those two things. I think this might be, is that flipped upside down? Yeah, it is. So I'm just going to grab it by the arrow there and just reorient it. So now we kind of have a dino Milner that's starting to emerge. You know, I think lining things up is something that people who are just starting out with Tinkercad would struggle with. And sometimes there's tools that you can use to like snap objects to objects, or there's a ruler that you can bring in. We're just going to keep it pretty loosey-goosey here today and just kind of try to drag things in place as much as possible. But if you were working on a more precise project that needed something that was a little bit more precise, there'd be some tools both in Tinkercad, but also other software programs too. So look at that. That's kind of, now we've got a bit of an imposing look to the Milner here. I wonder what else we could do. Let's see. We have dinosaurs. We have character shapes. Oh my goodness, we can put some cool shades on the library too. And maybe even on the dinosaur itself. So as we're doing this, I think this shows off the real creative power of this as a platform and of 3D printing in general. Obviously, with some of the overhangs I've created with that dinosaur and the fact that it's not grouped yet, that's going to be a bit of an issue. Actually, if I actually go to print this, I'm going to have to add some more structure in and make sure that those are joined. But I can definitely be very creative, be very playful, get kind of a general idea for what I want to achieve as I'm building my 3D object. Oh, I just lost a little bit of my, ooh, sometimes you lose things inside the building and you have to shuffle things around a little bit, just like in real buildings. And I'm just gonna raise on the Z axis. And there we go. Now we're starting to get kind of a cool building going on here, kind of a pretty rad look for this building. So, I'm not sure if you download this object. It's available. I've posted it on Thingiverse, and if you downloaded the Milner model, you could make definitely something interesting of your own as well. There's a lot of possibilities. There's like little astronauts. There's bunny ears. We can add some bunny ears to the building as well. And again, just kind of acknowledging that this in terms of what we've got here so far, we do have a few unsupported angles, so we may need to, as we're getting it a little further along with our design, we may need to uh, make some changes to where things are positioned or what orientation they're in, so that we're not getting greater than 45-degree angles. We do, as I mentioned in the Q&A, have a printer that is able to print wash away supports, but you're still going to get some support scarring, and it's not always a foolproof process. So that's something we always say, supports are a last resort. I remember one of my staff who's been working with us for a long time, mentioned that. So, um, I've been showing you some of the basics of Tinkercad. We actually have a 3D print that's got started, and I'm just gonna take a break here for a moment. I'm gonna stop sharing my screen so that I can show you what's actually happening on the 3D printer. So I'm just going to bear with me. I'm going to kind of take my operation over there. Maybe you get a chance to see what's happening here today in the makerspace as well as I'm doing that. So we have some 3D printers behind us. We have the studios as we kind of saw before. We even have staff member Jermaine who's here. Thank you, Jermaine. Jermaine's got safety in mind there and has got the mask going on. And Jermaine set up a print on one of our 3D printers for us a little bit earlier today. So this is one of our Prusa 3D printers. And what we have here is a 3D printer fume extraction device. And there's, in some of the other 3D printers you saw behind me, there are full safety cabinet enclosures as well that have some other safety features like thermal runaway control and fire suppression, things like that that are important if you might be printing overnight in an institutional context like this. But our 3D printer is working on a little, it looks like a little whale model. Is that what it is, Jermaine? I'm looking over at Jermaine, and I think that's what we're printing today is a little bit of a whale. So basically you can see the 3D printer. This is a hot plate here, so I'm going to be careful with my hands. But we have the 3D printer going line by line. It's got basically this blue material that's coming down from the filament at the top. And we have essentially the hot end here and what's called the extruder that takes the filament and pushes it through into the hot end. The hot end, you can't really see it. There's a cooling apparatus that makes sure that everything is cool and that the material isn't overheating. It also helps with the finish on the print itself as well. There's one of these fans is kind of, the job of it is to point at the object that's being 3D printed and just cool that plastic down just a little faster to give it a really sharp finish. So as you can see, it's printing away. One of the things that I'll also talk about that, you know, when we're working in Tinkercad, you may not think about is, although we have a solid object, this whale object, we also have essentially the software has helped us create an infill pattern for the object. So instead of it being solid all the way through, which would take a lot of filament, it would be quite expensive potentially if we're charging 10 cents per gram, which is generally the cost recovery rate here at the library. What we would end up doing is paying a lot more, and we would have an object that isn't necessarily that much stronger. It would be definitely more dense. And so basically that with the infill, we get this box pattern, and I think this is about a 20% infill, might be 15 or 20. And what we're able to do is just basically have this shape, and it's a more efficient use of the filament. Some infill options, there's a honeycomb infill option, and that's a very strong option and also very efficient. So depending on what the project is and what people are trying to do with the 3D print afterwards, we might change the infill to make it denser, to make it lighter. We can actually also totally remove the infill if someone is wanting to make a hollow object or a vase. And that's a pretty popular thing. We've had people print vases before here at the library, and some really interesting patterns that are possible to make even with Tinkercad. So yeah, that's a 3D print that's actually up and running. I'm just trying to think if there anything else that I can tell you about the 3D printer. Maybe I'll just go over. Jermaine has set up a view on another computer. Because this is the future, we're going to show one computer screen with another. And basically this is what Jermaine is printing. So as you can see, it's a whale, and it's quite a cute little print. I don't think there's going to be too many issues with overhang for this one, but there are some areas like that tail that might need some extra supports. And if we just go back and have a look, oh, Jermaine's showing us what it looks like when there are software supports added. And this is something that we'll be teaching people about when they're doing their self-serve 3D printing. Yeah, as we go back and look at what's printing here for a second, you can see on the very back, there's, and I'm just going to use some tweezers. I'm going to angle this down a little bit. I'm going to use some tweezers so that it's safe. You can see that this is where the support structures to help with those areas that are a bit that are overhanging and that may get dropped essentially as they're being placed in thin air. That's the support material right there. And it's got this kind of interesting waffle pattern that allows it to actually break off a little bit more easily. It can leave some scarring, and that's why we mentioned, you know, support is a last resort. But yeah, some supports are, you can see them building in addition to the main object. So thanks for showing us that, Jermaine. So I'm just going to take us back now to Tinkercad for a second. Just taking a little walk through the makerspace. And for folks who are just leaving to see the rest of the program, thanks so much for joining us for this little class, little introduction to Tinkercad and to 3D printing. And we're really excited to have you come and learn how to use a 3D printer at the library, and really excited to see what you're going to make. So for those of you who are just signing off, thanks for spending some time with us, and enjoy the rest of the program. And for those who might want to stick around for another half hour, I'm going to show you some other things that you can do with Tinkercad. So I have been, you know, looking at some of the options that are available in Tinkercad itself. I'm just going to go back to my design that I was working on, even though it was a little bit silly. So here we are. So back looking at my design, we basically have the Milner. I'm going to take away that bunny ear, and I'm going to show you something that you can do on. One of the things that's so great about 3D printing is that people have been really sharing a lot of models. And at the library, like, we think it's really important that when you're learning to run a 3D printer, that you also go through the process of building your very own 3D model. So, you know, maybe it's like the hamster house that I mentioned before, or maybe it's something different, maybe a practical object, maybe something artistic or a piece of fan art. But we think it's really important process to try building your own model. But also, there can be so much fun that happens when you also play with other people's models as well. And there's a website called Thingiverse, and we use it quite a bit here with the public, where other people's models are available to play with. And so I'm just going to show you a couple of examples of things that we might bring into the process. So one of the things that we've loved to do since the very first Makerspace in 2013 is there's kind of like memes that get going under 3D printing, and people will kind of have a craze of doing a particular thing. And one of my favorites of all time is the beefy arms meme. It's where you take basically a pair of beefy arms and you add them to a project in some way. So, you know, I think a beefy armed shark was one of the very first ones. Also pretty old but still enjoyable is the Deal With It glasses. This is another one, kind of like the shades that I've already put on Milner there, but even a bit spicier if we put the Deal With It glasses on the building. So those are just a couple of examples. And, you know, Thingiverse, if you're a parent watching with kids, I will say that it's like any network where people are posting and sharing things. There's things that, like, you know, you just want to let your kids know that there might be some objects that, you know, are a little bit like, let's maybe not spend too much time there. They do have some moderation and some content stuff, but I think it's always good to be wise and just to kind of like have that discussion. But in general, really great resource for helping you to find inspiration or to kind of add some fun to an existing project. So I'm just going to see here if I can go ahead and import something that we have made in Thingiverse. I think I'm just going to, let's just see here. Just going to delete a couple of the objects, a couple of the ideas that I had earlier. See if we can get a pair of beefy arms in here to put on this building. Okay, I'm just going to see here. I think actually I had, yeah, I had these earlier. I think I can drag and drop. Let's just see. Oh, you know what? I can actually import them from a URL. Let's try that. Could work really well, could be kind of a disaster. Oh, didn't quite work. Okay, I'm just gonna pause my sharing for a second. I'll be right back with the sharing. And I'm just gonna grab that pair of arms and download them. All right. So I'm gonna start sharing again. Just a moment. All right, here we are. Oh, I was briefly on that other design, and it was something that a staff member had made a few years ago. Let's just see here. Oh, just having a little, I thought I grabbed it there, but I'm gonna have to give it another shot. Just 1 second. These live demonstrations are always the most dangerous of all types of demonstrations. Okay. All right, I'm just gonna share again. There we go. All right, so believe I've got it. We have a beefy arm, a final left beefy arm, and we're just gonna try to import it. It says importing beefy arm, imported. Now, I don't see it appear yet. I see our Milner with the heart on top, but where is the beefy arm? We might have to just look for it. Let's just see here. Oh, oh, do you see that? Let's get very, 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 very close. Here we have an extremely tiny beefy arm. So now now that we found it, we can do something about that scale. So remember I showed you earlier the tool where you can essentially make the beefy arm. You can kind of change its dimensions with a transform. So we're going to do that. We're going to grab, there's actually two of them here. So I must have grabbed it before, but I didn't realize it because it was so small. So I'm just going to start kind of playing here and see if I can get it into a scale that we'll be able to work with. Here we are. All right. So let's pull our Milner back here. We've kind of got everything all spread out. We lost our heart for a second, so we're going to grab that as well. All right. So I've rejoined the heart. Now we got the heart and the brawn. We're going to add that beefy arm here. We're just playing with the scale. And we're just rotating the angle there. And now look at that. We've got a really strong library, strong for the people of the city. Lots of heart, lots of brawn in our services. So there we go. We've got a beefy arm. And one of the things though, just speaking a little bit about that 45-degree angle issue, that we may want to just keep in mind is that this is a bit of, this is maybe manageable. It's not too sharp, but we could be at some risk up here in this part of the this part of the arm. So I think what we might do is we might just rotate this a bit further. Um, pretty interesting shoulders to support that, but I think that might help us in terms of helping with that overhang issue. So now I'm gonna take the beefy arm that we've added to the building and I'm going to group that. And there we go. We have something pretty special that's coming together here. Let's grab the other arm. There we go. There's probably, if I zoomed in and panned a little bit, there's probably an easier way of doing that. And let's just see here. If we adjust our angle, now this can be a problem in the gym if you only work out on one side. Get a little bit unbalanced. So we'll just see maybe if we can do a better job of matching the scale. Oh, and I've in kind of pulling the building around, I've also created an issue where I flattened it out a little too much. So I'm just gonna change on, I believe that would be the y-axis, so that it's a little bit more like it should be in terms of the thickness on that axis. All right, so there's my second arm, still a little bit unbalanced. There we go. And again, mindful of that 45-degree angle issue. We're just going to extend it a little bit here. Let's see how that looks. Yeah, those are looking pretty even. And now we're going to do that group command so that we get one solid object. So something that I don't think I've talked about actually is why it's important to do that grouping command. One of the issues that can come up with 3D printing and with digital design files is that sometimes if a 3D model hasn't necessarily been designed specifically by a program that's set up to export things really easily like this, like, in Tinkercad and some of the other programs out there like Blender and Fusion 360 either have built-in functions for exporting things in the STL format, which is the format we like working with. Sometimes they're set up so that they give you warnings, or sometimes the software that Jermaine and I looked at earlier with the whale will give you warnings about this. But sometimes what can happen is with some software or some situations, pieces of the face of the triangle, of each triangle that goes into the polygons that make up this object, sometimes the triangle might be missing, sometimes it might be facing the wrong way, sometimes it could be intersecting with another triangle. And this creates a lot of problems for 3D printers because especially the kinds of 3D printers that we work with, they they don't necessarily catch on. They don't have any sort of, like, the software is very good, but if you send an object that has a big hole in a part of it, the 3D printer doesn't know that you've made a mistake in doing that, so it will do its best to carry out your command essentially. And sometimes you can end up with failed 3D prints. We sometimes call them 3D spaghetti, huge kind of like bird's nests of filament, because a piece of filament has been dropped and then each successive piece of filament has been dropped after that. So in grouping things together here in Tinkercad, what we're trying to do is we're trying to create one object that has a single volume essentially. And it's called manifold. And a really good way of thinking about this, and I think an engineer might explain this a little bit differently, but for me, I explain it in this way. a really good way of thinking about it is that if this object, let's say that we could pour a glass of water into this object, if it's manifold, it doesn't have any holes. There will be no leaks. No leaks of that water. Nothing will spring loose unexpectedly. So that's the idea of being manifold. And if we had two separate volumes that were intersecting and they were considered solid objects, if we didn't group, then we would have kind of instructions that would cause problems for a 3D printer if we actually tried to run them. We'd probably get some software warnings, but it's a good thing for us to be aware of and to potentially avoid. So in terms of that group command, what we're trying to do is we're trying to get the 3D print or the model, we're trying to get it into one single kind of manifold volume so that we don't have anything that's intersecting where it shouldn't be. We don't have anything where it's going to cause problems as the 3D printer tries to carry out the manual commands. And they really are very manual. It's very like, go to X position, go to Y position, go to Z position, extrude this amount of filament. Like the 3D printers that we have, they use a coding, they understand a form of code called G code, and it looks a lot like computer programming code. It essentially is, and it basically gives line by line commands. So this object, it could be thousands and thousands and thousands of lines of code if we were to send it into the program that's called the slicer. That's what Jermaine was showing us earlier. That kind of takes the dimensionality from the STL and derives instructions based on both the machine settings and the software specifications as well. So there's a little bit that goes into that piece of it. Can be, as someone's first learning, a little bit mysterious to get part of, or to sort of get attuned to, in terms of you thought that the 3D printer was going to do this, but it actually did this. But those are really powerful programs for helping us to take something that we create in Tinkercad and see, like, is this actually going to print? And then, what are the settings going to be? What's our infill for this object going to be? So it's a really interesting process. I think as I'm talking about it, you can probably tell that I really love the process a lot. I think you can learn so much from doing it, and you can really come up with some interesting creations as well. So just going back to our Milner model for a second here, we've got some beefy arms on this building. It's got a really cool look. Let's just see if there's any other operations that I should tell you about. Well, there is the seasonal decor piece. We could get ready for Halloween. Could get ready for October by adding a pumpkin to the building as well. That's pretty fun. And that's also something that you could potentially do, and something that we've done in the past at the library for a kids class. We did a design your own 3D printed pumpkin program. That was really fun. So yeah, I guess now it's not too scary, but we're pretty much ready for the next season that's coming up here. Just trying to think. So I mentioned earlier that one of the things that we always like to see is we like to see things exported in that STL format, and maybe I'll show you that. We're just in case you're curious about that part of the process. So we have our Tinkercad is just working through on the group. I just am gonna, before I show you the export process, I'm just going to check that and see if it worked properly. I might have gone through that a bit fast. Interesting. It didn't join those objects up as I expected. Oh, maybe it did. So what I'm doing is I'm testing to see if in Tinkercad, usually when it's still two discrete objects, it allows it kind of, when you push one, the other one won't go with it. But in this case, it looks like even when I'm um, working with selecting the jack-o'-lantern or another part of the building, it's still pulling the whole thing. So we've kind of got a little bit of a monstrosity here, but in a good way. And we have this jack-o'-lantern. I was surprised because usually what happens is the color changes to match the existing color of the building, but here in this case, it stayed the same. So it might be something about the way that this jack-o'-lantern, something about the way that it's put together that's causing that issue. But not a huge issue at this point. So I'm just going to go ahead and just going to show you the options. So as I mentioned, um, the the uh, preferred format for 3D printing here is the STL file. And that's what we would be exporting this as and then taking it over into one of our slicing programs. And for our Prusa 3D printers, we use a program called Prusa Slicer. For our Ultimaker program printers, we use Cura, which is made with Ultimaker in mind. And so, depending, there's a few different other programs that are out there. That's just what we happen to be working with at this point. Another interesting thing is that you can make an SVG for laser cutting, and that's one of the other services that we're going to start to offer here at the new EPL Makerspace is access to a laser cutter. We're going to start first with preview workshops that'll be coming up, so you can watch for those. But so, yeah, a really interesting thing is you can essentially do like a 2.5 or 2D design, and then you can export it here into the scalable vector graphic format. That's the SVG format for laser cutting. So maybe what I'll do is I will just push our little Milner there, our little Milner to the side, and I'll show you something that would be fun to do if you were thinking about laser cutting. This model here, probably I wouldn't attempt it with a laser cutter. Yeah, there's a lot of reasons why, but it just wouldn't be a good one to go for. But something cool that we could do if we were thinking about laser cutting is we could, for example, take a shape. Let's start with maybe a basic shape as just a platform that we'll work on. So we'll go back to our good old box, and we'll basically just kind of flatten it out a little bit. And then we're going to go ahead and I'll show you this mode that I really love in Tinkercad that allows for a little bit of free form drawing. So we can potentially make a little design here. And I'm not sure about you, but something that I love to draw is like really weird creatures, like little, maybe are they creatures from out of this world? That's what I like to do when I'm drawing in Tinkercad. So I'll just show you an example of how that might work. So I just start by kind of freehand drawing. This is very familiar if you use Paint or other programs, really basic drawing programs. Um, so there I have like a creature, the start of a creature. It's got a very kind of funny Hershey's Kiss look to it. And I'm just going to, let's see here, maybe I will fill it in a little bit. And maybe I will create some eyes. This is something that I think is really fun to potentially show kids, because kids will be familiar with this kind of drawing. They're like to draw pictures, and you can kind of take that idea here and bring it forward into Tinkercad. And I'm just filling this in, and I'll show you why that is in just a moment. I'm just gonna color as quickly as I can here. Maybe turn this into a little smile. Maybe have a little nose. Maybe create a little bit of an eye here, a little pupil, maybe one on this side. Getting quite a silly looking creature going here. All right. And now I'm just gonna color the rest of this in. So there we have kind of a silly creature, and I did miss a few spots, so I'm going to go back and do that. But first I'm going to draw feet. Just going to fill in those spots because, as I mentioned, we don't want any like really small, strange holes that the 3D printer or the software will need to try to interpret. So we want that to be as kind of crisp as we can. And so there we are. And so now we can say done. And, if we made a mistake, like we could go ahead and let's say that we wanted some eyebrows, we could use the eraser tool to get some eyebrows for this creature. Or let's say we wanted that smile to be a bit bigger, we could do that as well. So there's quite a few things that you can do inside of Scribble. But let's say that we're done with that for now. And then we basically have just a little bit. We're just going to drop the creature in a little bit, just a little bit above. Now, as I mentioned in the Q&A, the CNC mill and the laser cutter are things that I'm actually still learning about myself. So if I were going to try to take this silly design and potentially take it to the laser cutter, I'd probably talk to my friend Jermaine over there and see, Jermaine, did I have I made any mistakes with the depth? Like, is this going to be too high? Should I maybe take away the base plate and stick only to the creature? If that turned out to be the case, what I could do is I could press undo. I could go back and I could kind of like remove the plate. So again, I'm still learning about those technologies, and I might go and ask one of the makerspace staff for help, which is, sometimes they ask me for help, sometimes I ask them for help. But yeah, I might, change things up depending on what, as I learn a little bit more about what that process of laser cutting requires. Um, but yeah, what I have right here is like a little cute creature. And again, if I was intending to take that to a laser cutting process, I'd put it into SVG. I'm guessing what would happen next is we'd probably load it up in Adobe Illustrator, perhaps for some fine tuning. The software that we're working with for our laser cutter is called Job Control. That's very similar to what we're working with for the 3D printers. So, depending on how well or how much work that needed, we would kind of see what needed to be done and then adjust from there. But that's a way that we could potentially use Tinkercad and some of its features if we're working with something like laser cutting as well. So that's pretty exciting. Oh, and there's our Milner building. It's still there waiting for us, hovering in midair, which is really fun. So I hope you've enjoyed just kind of going through the basics of Tinkercad, learning a little bit about the 3D printers, and you know, kind of seeing how this can be such a great place to play and to kind of make new things and also learn about 3D printing at the same time. Um, I, yeah, have really enjoyed showing people this today. And once we are open on the 17th, if you have questions about, coming in to use the 3D printers, when that's going to start, and any other questions that you might have, especially if you know a little bit about this already, you may have some more technical questions, and we're happy to answer those as well. But really looking forward to spending that time with you. And I think I'm going to let you go for today, and I hope you enjoy the rest of the program and have had a great virtual grand opening so far. So great, thank you so much, and have a great rest of your day, and come and see us at the new library as soon as you can. And yeah, looking forward to seeing you.